Hi everyone, welcome to another video. Now we're continuing on with our topic of exponential functions, and we looked in the previous video at the effect of changing this base number, making this number bigger and seeing how that affected the steepness of our graph. Now we're looking today at a couple of more transformations, because what we did in the last video was just the effect of doing something to our regular sort of base function, our regular y equals 2 to the power of x, changing something about that and seeing how that changes the graph. Now we're going to be doing a very similar thing, and we are looking at two particular transformations here. So I have my y equals 2 to the power of x graph here, and we saw the effect of the base number. Changing that essentially ends up being something that happens to the y value. Is it doubling? Is it tripling? Is it quadrupling, like we looked at in those previous examples in the last video? Now what we're doing now is we are putting a negative in front of my base. So we're going to see what ends up happening here. Now, if you've watched some of the previous videos where we've talked about translations, some of you may already be guessing what this is going to end up leading to, but for these next two transformations, we are going to take it really slowly, investigate it using a table of values. Now, for this, I'm going to draw myself a nice big table of values again, and I'm going to include a few values of x. So I'll go -2 all the way up to +2. Okay, and substituting this here, I get -2 to the power, or -2 to the power of -2. 2 to the power of -2 is 1/4, or 1/4. So that's going to give us, since there's a minus in front, -1/4. Putting in this 1, that gives me -1/2. Now you guys can check this in your calculator as well, so please do that, see what happens. And -2 to the power of 0, that's going to give me, anything to the power of 0 is 1, and we have a negative in front, so that's going to be -1. Here I'm going to get -2 and then -4. Please feel free to just verify these values by substituting in your values of x into here, and just double check that you're getting those numbers. But if we were going to draw this now, let's get an x and y axis happening. And what we're going to do is plot these particular points. Now when x equals to -2, let's include these points in here. We have 0, 1, and 2. When we put in x equals -2, y equals -1/4. So that's going to be kind of around here-ish. So my first point is going to be right here. When x is -2, y is -1/4. Now when x is -1, y is -1/2, so that's going to be around there. See, that lines up here to about -1/2, halfway between 0 and -1. And our next point, when x is 0, y equals -1. When x is 1, y equals -2. And when x is 2, y equals -4. So that's like roughly down here. So if we connect the dots, and now if we subbed in values sort of on this side of -2, so smaller and smaller values, it would still be a negative value of y, but that negative value of y would approach 0. So we'd get -1/8, -1/16. It's going to get closer and closer and closer to 0. So if I sketch this, if I connect the dots roughly, that looks pretty shocking. Let's try that again. If I connect these, I'm going to get something that looks like that. And it's going to keep going. Now this is the equation y equals -2 to the power of x. Now let's compare that to the one I had up here. it looks very similar. The y values are actually the same as these, the same magnitude, the same number, but they're just negative values. So the graph has been transformed in a type of way. It looks kind of the same, but notice it's been flipped. It's been flipped around this x-axis. Sorry, I haven't labeled my axes in. This is my x-axis. This is my y-axis. I have vertically reflected this. I have gone from something that lived up here, and I have reflected it along my x-axis. Now, if you remember, we did this exact same thing with parabolas a while back. We looked at when we have a negative number in front, this leads to a reflection. This is a reflection in the y direction. So this negative here is acting on the y. And we can see because every value in the y, like every y value here, instead of being positive like up here, for example, we had positive 1, positive 2, positive 4, everything is negative. These here are the same numbers, but they just have a negative here. So this is a vertical reflection. And that's why I get something that looks like this down here. Everything's kind of similar. It looks roughly the same, but all of the y values are reflected. All the positive y values of my original thing, y equals 2 to the power of x, that has been reflected. And that negative in front here tells us that type of reflection. So we stick a negative out front, that means some kind of vertical reflection. And we're going to look at one more transformation here to finish off this video. That is going to be y equals 2 to the power of minus x. We're going to see what this thing actually ends up doing. So notice that before with my original parabola here, there's nothing in front of this x here. So with all numbers, when there's nothing in front, we just assume the sign is positive. So this is positive 2 to the power of positive x. Here, we are changing the sign in front of x from positive to negative. And we're going to see what this ends up being. Okay, so I'm going to do these same values, and I'm going to substitute them in. Now, this guy here, putting this in place of x, this is like saying 2 to the power of negative 2. So I have two negatives here, so that's going to give me a positive. So 2 to the power of minus 2 is like saying 2 to the power of 2. 2 to the power of minus 2, this double negative becomes a positive, giving me 2 squared, or 2 to the power of 2. So this thing here, 2 to the power of 2, that gives me 4. Now here, 2 to the power of negative minus 1, negative 1 gives me 2 to the power of positive 1, which just gives me 2. 2 to the power of negative 0, well, whether I have negative or positive 0, that's just still going to be 0. It's just nothing. Anything to the power of 0 gives me 1. And now over here, this is where we have to be careful with the signs. 2 to the power of negative, putting 1 in place of the x here, just gives me 2 to the power of negative 1. And from previous examples, we saw that was a half. And finally, 2 to the power of negative 2, with this 2 in place of the x, gives me 1 over 4. So let's sketch this out, see what we end up getting. Okay, let's put in some values here. We get -1, -2, +1, +2, and we get 1, 2, 3, and then 4 up the top. Okay, so let's sub these values in. When x is -1, y is 4. So, sorry, when x is -2, y is 4. So that's like all the way up here. When x is -1, y is 2. So that's about here. When x is 0, y is going to be 1. When x is 1, y is 1/2. That's here. And when x is 2, y is 1/4. So that's like down here. So connecting this up, let's do that again. Connecting this gives me something that looks like this. Y equals 2 to the power of -x. Now, let's compare that to y equals 2 to the power of x. So this thing here was something like that. 2 to the power of x. What do we notice is happening here? Well, it looks kind of the same. So like it's still increasing at the same rate. My y's are going up here. I'm sloping up at about the same rate. But there's one thing that's slightly different. And hopefully you can see this, but say I had a mirror right down the middle here. You can see that each graph here is a mirror reflection of the other. So what I've essentially done is the effect of this negative here in front of the exponent, that is going to be another type of reflection. But here, this is a horizontal reflection. We're reflecting along this line here. In the previous example, we reflected along the x-axis. Here, we are reflecting along the y-axis. And we get a pretty interesting and kind of nice looking transformation. Everything's the same, but all the x values are negative. So the negative x values produce the same positive y. So that's the effect of this negative here. This negative is acting on the x. So this is a horizontal reflection. Everything is getting reflected around my y-axis. So this is the effect of these signs here. We have when the negative is acting on the exponent, on the power, we get a horizontal reflection. And when it is acting on the, when it is here, it is acting on the y. So this, I've just written reflection, but this is a vertical reflection. And this is the effect of these two. We now have looked at another two types of transformations of my exponential graph: vertical reflections and horizontal reflections. That brings us to the end of today's video. Thank you so much for joining me, and I will see you next time.